Back to everybody's favorite thing, the transformations of the graphs. Since we've looked at the parent functions and saw what they looked like, now we want to start looking at how the different pieces could affect that parent function to make it look different. So these are the same rules that we've been working on since the beginning of the school year, but I just want to draw your attention to where you would identify certain transformations on radical functions. Now, these are all square roots that are mentioned here in the examples, but it's going to be exactly the same for cube roots or any other type of radical that we might work with. So a horizontal translation, remember the sign is always going to be the opposite. So since this is -2, we end up going to the right. And since this is +3, we end up going to the left. And you'll notice that that happens underneath the radical because we're only changing the x. A vertical translation, you notice, happens outside of the radical. So that's the main difference there, just like it always has been. Now, a reflection over the y-axis is going to happen under the radical, and over the x-axis is going to happen outside of the radical. Remember, over the y-axis is almost like describing a horizontal reflection, and over the x-axis is like describing a vertical reflection. Horizontal stretches and shrinks, those are also going to happen inside the radical because they're horizontal. Everything horizontal happens underneath the radical. And notice again that we do the reciprocal on horizontal stretches and shrinks. Lastly, we have the vertical stretch or shrink, which I know you can't see that bottom example underneath the writing. It says 1/5. You'll notice that vertical happens in front of the radical, and that one stays exactly the same. So that first example there is a vertical stretch by a factor of 4. All of those rules are still in play as we move forward and look at how we can transform these functions. So here is the first example. We want to describe the transformation of f represented by g, then graph each function. So what I can see here is we have two different transformations. We have a -3 under the radical and a +3 outside of the radical. So that tells us that from f to g, we have a horizontal translation that is 3 to the right, and we have a vertical translation that is 4 units up. The translations are the last thing that we're going to take care of. We're going to go ahead and do the stretches and shrinks in our table, just like we would on the previous examples where we didn't have transformations. And then we're going to move those points on our graph to accommodate those transformations. So we're going to set up an XY table with y equals the square root of x, just the base function. Again, since it's a square root function, we want to use perfect squares for our input values. So 0, 1, and 4 would be good ones to look at. 9 you could also include, but 3 points is probably going to give us enough of an idea. So the square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. So those are going to be our first 3 points. Now, I had shown you guys to kind of put little X's instead of graphing the dots, so you remembered that those were your marking places, but that's not where you were going to stay, because now we're going to take those points and do those transformations. We're going to take each of those and go 3 units to the right and 4 units up. So 3 to the right, 4 up would put me here, 3 right, 4 up would be here, and then 3 right, 4 up would be here. Now remember, this graph stops at 0. It does not connect through. So our graph is only going to be this little section right here. And so that is our transformed graph. Since it said to graph each function, I guess we could go ahead and make these into dots and graph the other one there. So you can compare the two. This one is f of x, and the orange one is our new function, g of x. Okay, let's look at another example. Same thing here, but we're working with a cube root function. So the changes that are made to the cube root of x we can see there are a couple of different things. One is that we have this negative here, and since it's underneath the radical, that's going to be a reflection that's horizontal, so that means it would go over the y-axis. And then we have 8, which is a horizontal shrink because the reciprocal of that is going to be 1/8. So to list out our transformations, we have a reflection over the y-axis, and we have a horizontal shrink since we do the reciprocal, and it ends up being, instead of 8, 1/8. So again, what that means is that's going to pull all of the points closer to that y-axis. The right and left side are going to suck in closer to that middle axis there. So let's go ahead and start with our xy table of our base function. That would be, we're going to go ahead and include the stretches and shrinks as our base function. I think that will be a little bit easier for you guys. So we're going to do y equals the cube root of negative 8x. Since there's no transformations that require translations left, right, up, down, then this will just give us our points, and that's going to tell us exactly where our function is going to be. So we can go ahead and plug in there. That's going to give us our g of x function. Remember, we want perfect cubes, and we can do negatives here. So I'm going to do -8, -1, 0, +1, and +8. That's always a good place to start. So when we plug in, we do -8 times -8, that's +64. So then we do the cube root of 64, which is 4. The next one is going to give us the cube root of +8, which is 2. This one's going to give us 0. And then these are going to give us the same, but they're going to end up being negative. The cube root of -8 is -2, and the cube root of -64 is -4. Now this is going to give us the transformed function. So I have -8, +4, -1, +2, 0, 0, 1, -2, and 8, -4. So it's going to look like this. And this is g of x. Now they did want us to graph the original function as well, so the parent function, the cube root of x, if we graph just the cube root of x, then we'll want to do -8, -1, 0, 1, and 8. We're just going to do the straight cube root here, so we end up with these values. So when we graph these on here, we're going to notice exactly what those transformations look like. So -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So you can see how it got compressed towards the y-axis, that's a shrink, and it was a reflection as well. So you can compare the two graphs. I'm going to do a couple more examples here. If you feel confident in this, maybe you go ahead and stop, try a couple, come back if you need some help. If you feel like you want to go through a couple more, I'm going to go ahead and do those now. So here's our next one. This does not give us the original parent function, but we can go ahead and figure out what that would be. This one has g of x is equal to the square root of x plus 1. Well, since it's a square root function, the parent function that we would have started with would be f of x equals the square root of x. So it didn't ask us to label it, but we should have it in mind that all we're going to be doing on this one is moving the points to the left 1 unit. So let's start by figuring out the x and y values of our parent function. Since it's a square root function, we can only do 0 and positives, and I'm going to pick perfect squares. So we get 0, 1, and 2 for our points. So if we graph those, 0, 0, 1, 1, and 4, 2, then we're going to take each of those and move them 1 unit to the left. So when I slide those over, I end up with a graph that looks like this. And you can see now that our domain has changed since we said, you're only going to get positives in your domain. By shifting this to the left, that added values into our domain that we didn't have before. So the domain would be x's that are greater than or equal to -1, because that's the first x value that we have is at -1, and then we continue on to the right. Our range, we want to look at our y values there. You see that our y values, let me pick a different color, our y values are going to start at 0 on the y-axis, and then they're going to keep going up this way. So our range this time would be y values that are greater than or equal to 0, and that's our domain and range. One more example, we start with the cube root of x, and we want it to become g of x is equal to the opposite of the cube root of x minus 2. So when we describe the transformations here, let's look at what they would be. We have the negative that's outside. That's going to be, you could think of it as a vertical reflection. Vertical would flip it over the x-axis. And then we have a down 2. So we have a reflection over the x-axis. And we have a vertical translation down 2. Now, our base function, the parent function here would be the cube root of x, but I want to go ahead and include any stretches and shrinks when I set this up. So I'm going to make a table for y is equal to the negative cube root of x. That way my stretches and shrinks are taken care of. All I have to worry about on my graph is moving it left or right or up or down. So when we make our table here, I'm going to plug in. These are cube roots, so I want to include my negatives as well. -8, -1, 0, 1, and 8. Again, the reason I'm picking 8 and 1 is because those are perfect cubes. So if I do the cube root of -8, I get -2, but then the -1 in front makes it +2. And then +1, 0, -1, -2, because we're taking all of our answers, the cube root of whatever, and then multiplying it by -1 because of the negative in front right here. So those are my ordered pairs. And I'm going to go ahead and mark those. So I have -8, 2. Remember, these are not our final answers. -8, 2, -1, 1, 0, 0, 1, -1, and 8, -2. And then each of those have to go down 2. So I'm going to move each of those ordered pairs down 2 spaces. And so our final graph ends up being like this. And let's label it. This was g of x. And they did ask us to graph the original parent function, which, again, you can go ahead and make a table there. This is just for the cube root of x. -8, -1, 0, 1, and 8. So we'd get -2, -1, 0, 1, and 2. -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. This was f of x. And that's all there is for that.